Hey, welcome to the video presentation on estimation. And before watching this video, I'll request you to watch videos on how to round off numbers to their tens, to hundreds, to their thousands. And if you have watched those videos, then that's completely fine. You can proceed on with this video. Otherwise, I'll request you to watch those videos and I'll provide their links in the description below. So anyways, I assume that you have watched those videos, and so let's begin with this one. So in the previous videos we saw that why we do estimation, that what's the importance of estimation, and in this video we'll see how to do estimation. Well, in your book you'll find a general rule of estimation. You'll find a general rule of estimation, and according to this rule you always round off numbers to their greatest place. So this general rule of estimation you will find in your books, but you cannot use this general rule always. And let me explain you with an example that why we cannot use this general rule of estimation always. So we have to perform this multiplication, that is 249 times 34, and the exact value of this multiplication is 8466. Well, this value is not known to you. Okay, you do not know this value. I've just written it here so that we can cross check our estimation. So the very basic of estimation is that whatever estimated value comes, that should not deviate too much from this exact value. Okay, so you'll say that, hey, when I don't know the exact value, then how will I decide that whether my estimation is correct or not? So very good question, and the answer for this question is that we do not have any certain rules to find the estimation. We do not have any rule or any steps to find estimation. It all depends upon the question or upon the condition, right? So here, if you'll apply the general rule of estimation, so the first number is 249 and it has ones, it has tens, and it has hundreds place, right? Ones, tens and hundreds. So the general rule of estimation says that round off numbers to their greatest place. That means that you will have to round off 249 to their nearest 100, and to do that we know that we'll do it like this. Let me take some of these. This is so the two close hundreds will be 200 and 300. These are the two close hundreds to 249, and in center will come 250, right? And our number is 249. Our number is 249. To round off this 249 to its greatest place, we'll round off 249 to the nearest 100. Okay, so we have 249. So 249 is nearer to 200 than 300. So 249 will be 200. Now comes the number of 34. We have ones and we have tens place. So according to general rule of estimation, we'll round it off to its greatest place. That is, we'll round off 34 to its nearest 10. And to do that, you have the two close tens will be 30 and 40, and in between will be 35, right? So these are the two close tens. Our number is 34 it's 34, and 34 is nearer to this number, so this will be 30, right? Now 200 times 30, right? We have using the general rule of estimation, we have rounded off these two numbers, therefore this will be 230. The answer will be 6,000. Right, now you'll see that this is 6,000 and our exact value is 8,466, right? It's very far from this exact value. So why don't we apply some other way to solve it? Okay, so check for 249. If I round off 249 to its nearest 10, okay, nearest 10, that is, if you will see this 249 and its nearest 10 will be, so this is 240, this is 250, right? And in between will be 245. What we are doing is we are rounding off 249 to its nearest 10. Okay, so the two close tens for 249 will be 240 and 250, and in between will be 245. Our number is 249. So 249 is nearer to 250, right? So this will be 250. Now let's see for 34. This is 34, and if we round off 34 to its nearest 10, so from here we know that it's 30, right? From here we can see that it's 30, we have seen here. So this will be 30. Okay, so now if we multiply 250, that is this value, we have rounded off 249 to its nearest 10, it's 250 times 30. So this value will be, you have two zeros, so put two zeros here, and then 3 times 25, this will be 7500. Now check this value 7500 and this value 6000. This was much easier way that we applied general rule of estimation, okay, and we got 6000. But here we didn't apply general rule of estimation. In fact, we applied depending upon the condition of this question. We saw that, okay, it's 249. What if I round it off to its nearest 10? Okay, so if we round it off to its nearest 10, we get 250. Okay, and if we round it off its 34 to its nearest 10, we get 30. So this time it's 250 times 30, and here it was 200 times 30, right? And this is 7500. So which of these two, that is 6000 and 7500, which is much more nearer to 8466? Of course this one, right? This one is much nearer. Therefore the answer will be, the better estimation will be 7500. I'll say the better estimation. Always remember, there are no certain rules to find the estimation, and there cannot be only one estimation of any question. Like in this case, even 6000 is also completely fine. It's fine. But which one is the better estimation? 6000 or 7500? Of course 7500 is a better estimation, because even in this case our multiplication was very easy. Okay, so we have to keep two things in our mind, that if we are making some adjustments, that if we are rounding off numbers, then it should always be like a minimal deviation from the original value. That if you are increasing any number, it should be a little bit, or if you are decreasing the value of any number, it should be a little bit, and if you are increasing the value of any number, it should be a little bit. It should not deviate too much from the original value, right? Like in this case it was 249, so here it came 200, by applying general rule of estimation. But if you see here, when we do not apply the general rule of estimation, we get 250. Okay, so this was the point number 1, that always make adjustments depending upon the question, but it should not deviate too much from the original value. And the second thing is like in this case it was multiplication, that should be, the calculation should be easier. It should not be like you have made some adjustments and your calculation is getting very tough. So there's no point in making such adjustments. So in this case it was 8466 was the original value, and we didn't apply the general rule of estimation, therefore we got 7500. Let me take one more example. In this case it's 63 times 182, and the exact answer is 11,466. Well, you do not know this value, right? You do not know this value. Now the first thing in your mind will come that, okay, let me apply general rule of estimation. If you apply the general rule of estimation here again, so this is 63, right? It has ones place, it has tens place. So according to general rule of estimation, you will round off 63 to its nearest 10, right? So the two close tens will be 60 and 70, okay, and in between will be 65. These are the two close tens to number 63, and our number is 63, right? And it is nearer to 60, so this 63 will be 60. Now let's see for 182. This is 182. We'll round off 182 to, sorry, first of all, this has ones place, this is tens place, this is hundreds place. We'll round off 182 to its nearest 100, and that will be, so you have two close hundreds to 182. One will be 100, right? And the next will be 200. In between will come 150, and our number is 182. This will be somewhere here, and 182 is nearer to 200, right? So if we round off 182 to its nearest 100, it will be 200, right? Now if we apply these numbers here, we'll have 60 times 200, and the answer will be, so you have 3 zeros, you have 1, 2 and 3, and then 2 times 6 will be 12, so you have 12,000. Okay, so you got one answer, one estimation by using general rule of estimation. You have 12,000. Now let's do not apply general rule of estimation. Can there be another way? Yes, of course there can be another way, just we did in the previous example. For number 63, you round it off to its nearest 10, like same in this way. Here it will be 60 again, using this method, right? But for the number 182, like here we rounded off 182 to its nearest 100. What if I round off 182 to its nearest 10, so that we deviate little bit from its original value? So the two close tens for 182 will be, one will be 180 and the next one will be 190. 185 will come somewhere here. Two close tens for 182 will be 180 and 190. Our number is 180, so 182, so suppose it comes here, 182. 182 is nearer to 180, and therefore the round off value for 182 will be 180. Remember, in this case we haven't applied general rule of estimation. We have rounded it off to its nearest 10. Here we rounded off 182 to its nearest 100 using general rule of estimation, but here we rounded off 182 to its nearest 10. So this is 60 times 180. You have 1 0, you have 2 zeros, so 1 and 2, and then you have 6 times 18. So this will be 48 and 4, 10800, right? 10,800. So 10,800. Now, as I said in the previous example, that we do not have a certain rule. There cannot be a fixed rule to find the estimation, and we cannot have only one estimated value. We can have number of estimated values, and we always pick up the closest one, that is the closest one to this original value. Well, in this case you will say that I don't know the original value, but here in this case you applied general rule of estimation, that is 12,000, and here you applied you didn't apply general rule of estimation, you have 10,800, and these are pretty much, you know, close values. Okay, so even you can take this one or you can take this one. These both are correct answers. There is nothing wrong in these two. Okay, it's not like 12,000 is a better answer estimation and 10,800 is a bad estimation. It's not like that. Both estimations are good. Someone will say that, hey, it was much easier for me to multiply 60 times 200 than 60 times 180. That's completely fine. But someone will say that, hey, even this was completely okay for me, that I can easily multiply 60 times 180. There is no big deal in that. That's also completely fine. But this is the last example, and here you don't have any other option. You don't have any other option other than the general rule of estimation to solve the problem. Like I said now, that you don't have a fixed rule, and it all depends upon the situation, upon the question, that what problem you are solving and what type of number, what kind of number is that. In this case you will see that, hey, you have 263 and you have 483. Now if you round it off, like in this case we rounded off to its nearest 10, right? In this case, and in this case also we rounded off to the nearest 10. Even in this case we rounded off to its nearest 10, and here also we rounded off to the nearest 10, right? So the main point was that the deviation from the original value, that either if we are decreasing the original value, then it should be a little bit, or we are increasing the original value, then it should be a little bit. But you cannot apply that concept here. Like if you try to round it off to its nearest 10, okay, if you try to round it off to its nearest 10, so to nearest 10 for 263 will be 260, right? How? You have two close tens will be 260 and 270. In between will be 265. Your number is 263. 263 is closer to this one, and this is 260, right? So you will say that, okay, this is 260. Similarly, for 483 it will be nearest 10, two close tens will be 480. This will be 490. In between will be 485. Your number is 483. 483 is nearer to 480. You will say that, okay, this is 480. But now how will you multiply this one? Like you have two zeros, you will write two zeros here, but now, sorry, now you have 26 times 48. That's not an easy calculation, and so this particular method of estimating value will not be an easier one. So in such conditions, right, in such conditions, always follow the general rule of estimation. So according to general rule of estimation, your 263 has ones, tens and 100. So you'll round it off to its nearest 100, and the nearest 100 will be, like in this case it will be 200 and then 300. In between will be 250 your number is 263. This is nearer to this one, so the rounded off value for 263 will be 300. Similarly for 483 it will be 500. For 483 it will be 500, just as we did here, right? The same, it will be 500. So now your calculation will be 300 times 500. This will be 1, 5 and 4 zeros, right? So 1, 2, 3 and 4, right? So this will be your answer. This will be your estimation, right? And here, when we were not using the general rule of estimation, well, this calculation was really tough for us, because how will you multiply 260 times 480 in your mind? That's not easy. But here in this case it was much easier. So again, so what's the basic point is? Point number 1, there is no exact rule or the fixed rule to find the estimation. It always depends upon the question asked, and always first try to make adjustments in the original values by either decreasing it a little bit or increasing it a little bit. This should be the first one. Like here we applied, okay, let's round it off to its nearest 10. But if we round it off to its nearest 10, our question, we got some values that was not easier to calculate. So that's why we went for general rule of estimation, right? I hope the concept is now clear to you. In next series of videos we'll discuss for multiplication, for addition and for subtraction, separate videos. Okay, thanks for watching.